The daring task of constructing tunnels and mega bridges through the most difficult mountainous area falling in Udhampur-Srinagar-Baramulla rail link USBRL project between Katra and Banihal in Jammu and Kashmir has been a big challenge for Indian Railways. USBRL, a 272-kilometer long rail line project, could easily be described as one of the biggest and most challenging railway projects in the world. Though the construction of maximum tunnels from Katra to Banihal has almost been completed, the construction work of Tunnel 49 is going on in full swing. Despite the fact that engineers working here are wrestling with some unprecedented challenges, mostly the sudden varying geological conditions. T49, having the opening portal at Sumbar near Sangaldan and the exit portal in Arpinchla near Banihal, has been split into two parts, A and B. Part B, from Addit Higni to Arpinchla, has been awarded to Afcons Infra Limited by Ircon International Limited. Tunnel 49 Part B, one of the toughest parts of the long tunnels on USBRL project, will be another engineering feat. Like all other tunnels in this project, new Austrian tunnel method, NATM, is being adopted for constructing this tunnel. The main features of NATM are mobilization of the strength of rock mass, shotcrete sealing, measurements, flexible support, closing of invert, contractual arrangements, and rock mass classification, which determines the support measures. Structural analysis, including effect of seismic forces for final lining of the tunnels being constructed in this section, has been done with extra care, being the most difficult part of this project, both in terms of logistic and geological strata. The geological features of this difficult terrain, especially from Katra to Banihal, are not friendly to the engineers on job. Exploring ahead of the path of a tunnel is particularly necessary for location of possible high water inflows and permitting their pre-treatment by drainage or grouting. When high pressure flows occur unexpectedly, they result in long stoppages. Blasting is carried on in a cycle of drilling, loading, blasting, ventilating fumes, and removing muck. Since only one of these 5 operations can be conducted at a time in a confined space at the heading, concentrated efforts to improve each have resulted in raising the rate of advance to a range of 40 to 60 feet per day, or probably near the limit for such a cyclic system. A hillside tunnel entrance is called a portal. Tunnel 49B starts from the end of a horizontal tunnel driven principally for construction access and called an adit. There are 2 adits constructed in Part B of T49. The Higni adit is 275 meters long, while the main tunnel from Higni adit towards T49A, single track, is 4018 meters long. Similarly, escape tunnel from Higni adit towards T49A is also 4018 meters long. According to international standards, any tunnel longer than 3 kilometers requires an escape tunnel for emergency. The escape tunnel running parallel to the main tunnel has already been completed. Again, the length of adit at Kundan Nala is 729 meters up gradient, while main tunnel from Kundan adit towards Higni's single track is 2,175 meters long. Main tunnel from Kundan adit towards Bridge 4, single track, is 1,127 meters long. The stretch of tunnel is encountered with the worst geological conditions, where we come across squeezing rock class, which is considered as the worst rock class in geological terms. To counteract this situation, heavy reinforcement of 25 mm dia with deep invert is added in design of the tunnel. At a junction towards T50 main tunnel of length 1465 meters is also up gradient. Another main tunnel T50 P2 towards Bridge 4, which is double track, is 255 meters long. While it is 338 meters long from Bridge 4 towards Kundan Adit in double track. Bridge 5 will connect T50 with Arpinchla Station Yard. Shotcrete is small aggregate concrete conveyed through a hose and shot from an air gun onto a backup surface on which it is built up in thin layers. Regular drainage and pressure relief holes or weep holes are drilled to drain out the seepage water pressure developed behind the face, and the water is diverted to the drain channel. High-speed drills with renewable bits of hot tungsten carbide are positioned by power-operated jib booms located at each platform level of the drilling jumbo. Truck-mounted jumbos are used in larger tunnels. For safe working condition inside the tunnel, ventilation is vital, both to provide fresh air and to remove explosive gases such as methane and noxious gases including blast fumes. While the problem is reduced by using diesel engines with exhaust scrubbers and by selecting only low-fume explosives for underground use, electronic equipment in tunnels is prohibited since stray currents may activate blasting circuits. Thunderstorms may also produce stray currents and require special precautions. The loose materials are also scaled and removed using excavator fitted with swiveling bucket. The mucking in the adit and main tunnels is carried out by slide tilting loaders of bucket capacity 1.8 cubic meter. The muck is removed in 25-ton capacity dumpers and spoils are dumped in the approved mucking yard. Welded wire mesh is fixed to rock with sustainable fasteners, for which the required drilling will be carried out with a handheld drilling machine. After the installation of structural steel supports at required locations as per the support class, the shotcreting is done to appropriate thickness as specified in respective support class. Dynamite, the usual explosive, is fired by electric blasting caps, energized from a separate firing circuit with locked switches. A complete set of dewatering pumps of 10 HP capacity with accessories are installed inside the tunnel to dispose the ingress water. Concrete of approved mix design M30 is batched and mixed in a batching plant and transported to the site in transit mixer. Setting time for concrete is 10 hours. Curing is done for 14 days after concreting. The invert is generally concreted first, followed by the arch where forms must be left in place from 14 to 18 hours for the concrete to gain necessary strength. The final operation consists of contact grouting, in which a sand cement grout is injected to fill any voids and to establish full contact between lining and ground. Rock bolts are used to reinforce jointed rock, much as reinforcing bars supply tensile resistance in reinforced concrete. Rock bolts have major success in providing the sole support for large tunnels and rock chambers with spans up to 100 feet. Installation of rock bolts involves drilling, grouting, hydraulic drill jumbo with basket, water pressure pump and torque wrench, shotcrete application through sprayed concrete pump and robo-arm. For this, they are placed promptly after blasting, anchored at the end, tensioned and then grouted to resist corrosion and to prevent anchor creep. There will be another hilly station at Arpinchla, which falls between Sumbar and Banihal stations on the line. The work on this station is going on in full swing. The station will fall between T49 and T50. For logistic support to the men at work and to reach the construction sites, various approach roads connecting inaccessible hilly habitations of the area have been constructed by Ircon International Limited in this section. Since the Banihal-Baramulla rail line has already been constructed and trains are running on it, the Katra-Banihal rail line, once completed, will link the Kashmir Valley with the rest of the country and will go a long way in integrating the people of Jammu and Kashmir into the national mainstream. In other words, after its completion, this project is going to give a considerable boost to the development and economy of the state as well as the country.